Okay, magandang araw po. So let's solve a sample problem here regarding flow nets. So we have the sheet pile is driven in the Cebu South reclamation area and the area to one side is pumped down as shown in the figure in our flow net. The permeability of the sand is given 0.001 meter per second. Below elevation 20 meters, we have an impermeable rock layer. And we are required to determine the flow per unit length and the pressure at point A at elevation 22 meters. Okay, for the topic of flow net, it is subdivided into two categories. First one is kung meron tayong isotropic layer of soil. In isotropic condition, we assume na yung soil particles sa layer na yun ay perfectly sphere at pare-parehas lahat ng soil particles. Pare-parehas yung shape and then yung size nila. So, pag pare-parehas mismo yung ating size and shape ng ating soil particles doon, we assume that the flow in all direction ay pare-parehas. And then, we can say that the hydraulic conductivity in all direction, say that is X, pare-parehas mismo. So, K is equivalent to Kx and then equivalent to Ky in all direction. At para makuha natin yung flow doon, that is, we will use this formula. That Q is equivalent to Kh NF over ND. And then, yung isa naman, yung kabaliktaran ng isotropic condition, we have the non-isotropic condition. So, non-isotropic, the flow in all direction ay hindi pare-parehas dahil yung ating soil particles doon ay hindi rin pare-parehas. So, po pwedeng mas mabagal yung isang flow sa direction na yun, po pwedeng mas mabilis naman yung flow sa ibang direction. So, therefore, yung ating hydraulic conductivity sa X direction ay hindi parehas sa hydraulic conductivity in Y direction. At para makuha natin mismo yung average hydraulic conductivity, that is just the square root of the product of the hydraulic conductivity in X direction and Y direction. Then pag nakuha nyo yung average hydraulic conductivity, apply to this formula, Kh NF over ND. Okay, back to our problem. The first requirement is the flow per unit length. So use this formula, Kh NF over ND. Ang tanong, nasa anong condition tayo? Kung mapapansin sa problem, iisa lang naman yung hydraulic conductivity na binigay. Therefore, we will assume na nasa isotropic condition tayo. Okay, so therefore, meron na tayong value ng K. That is 0.001 meter per second. H is the head loss. And that is just the difference of the elevation of the water in our upstream and downstream. So that is 30 meters minus 27 meters, equivalent to 3 meters. NF is the number of flow lines. So paano magfo-flow yung tubig natin from upstream to downstream? At meron daw tayong tatlong way. As you can see, meron tayong mga numberings dyan. Yung isang way, nagta-travel sa edges ng ating sheet pile. Dito. Pangalawang way, ito. Pangatlong way, ito. So we have 3 number of flow lines. And then ND is number of drops. And as you can see in the figure, meron tayong 6 na number of drops. So apply to the given equation of flow. Kukuha na natin yon. K is 0.001 meter per second. Head loss is 3 meters. And F is 3 over ND 6. So, calculating Q, that is equivalent to 0.0015 cubic meter per seconds per meter length of the soil. And that will be our first requirement. For the second requirement, we have to compute the pressure at point A at elevation 22 meters. Nasaan yun? Ito mismo. So, para makuha natin yun, lang natin. So, para makuha natin yun, we will just put a pipe at point A. Pag naglagay tayo ng pipe kay point A at elevation 22 meters, tataas yung tubig doon at a certain height. At yun yung aalamin natin. So pag tumaas yun, at a certain height, pag nakuha natin yung pressure head dito, makukuha na natin yung pressure sa point A. Ngayon, ang tanong, ano yung elevation ng tubig doon? So para makuha yung elevation ng tubig doon, we will analyze the equipotential drop. And equipotential drop is just the ratio of the head loss and the number of drops. And that is equivalent to 3 meters over 6, equivalent to 0.5 meters. Ang ibig sabihin lang nito, at every drop, bababa yung elevation ng tubig ng 0.5 meters. Okay, for this first point, ang elevation ng tubig ay 30 meters. Ito yung first drop natin. So, bababa daw ng 0.5 meters. Ibig sabihin, pag naglagay tayo ng pipe dyan, ang elevation ng tubig dyan ay 29.5. Dahil bumaba ng 0.5. Second drop, eto. So, pag naglagay tayo ng pipe dyan, ang elevation ng tubig, 29 meters na lang. Ito yung third drop, 28.5 ang elevation ng tubig. 28 meters, 27.5. And for the last point, 27 meters yung elevation ng tubig. Okay. So, nalaman natin mismo at point A, yung elevation ng tubig ay 27.5 meters. Therefore, makukuha na natin mismo yung ating pressure head. And that is 27.5 minus 22 meters. That is equal to 5.5 meters. And since pressure ang hinahanap, we know that pressure is equivalent to gamma H. So, applying to the formula, we have the unit weight of water that is 9.81 kilonewton per cubic meter multiplied by the pressure head that is 5.5 meters, and that is equivalent to 53.9 kilo Pascal. And that will be the requirement, excuse me, and that will be the requirement for this given problem.